Well, folks. It's been a while that I uploaded the video. Welcome to this session. And before I start, if you are new to my channel, please subscribe, share these videos with other people, with your folks out there, and don't forget to hit the notification button. So today we will be focusing on the sequences. Let's just hop into it. Okay, now I want us to divide this into two, because we'll be dealing with two types of sequences. Okay, suppose you are given the following numbers. You actually have a number here which is 1, 3, 5, 7 and up to Tn. I'm still going to explain what the Tn means. So when you say a sequence, you are actually saying these are numbers that follow one another. Okay, they follow one another in a row, following a particular pattern, so to say. So now the first term will actually denote it by T1, T2, T3, so on and so on. So when you say T1, you mean this is the first term in the sequence. Okay, this is the first term in the row of numbers that follow a particular pattern. Then term 2, term 3, term 4. Right? Then up to Tn, up to that particular term that we don't know. Right? Now we can actually compare this to another row of numbers, another sequence. So by default, because this is a sequence, it will still be T1, T2, T3 and T4. But now I want us to look at the difference. You know, in mathematics, when you say the difference, you mean this is actually a subtraction between two numbers, isn't it? When you multiply, the answer that you get, that will be the product. You add, that is the sum. You divide, that is the quotient. But now we are looking at the difference between term number 1 and term number 2. So in simple terms, if you say 3 minus 1, then you get a 2. You say 5 minus 3, you also get a 2. Then you say 7 minus 5, you get a 2. So this number, this 2, is actually constant. It is common. It is a common difference between any two successive or any two consecutive terms, any two terms that follow one another in this particular pattern. Okay, so as long as you can have a sequence whereby the difference between successive terms is constant or is the same, then we can actually say that is a common difference. That is a constant difference. And any sequence that has a common or a constant difference, the first constant or common difference, then you know you're talking about the arithmetic sequence. Okay? But now let's check the second one. If you check the second one, if you can say 4 minus 2, it will be a 2, and then 8 minus 4, it will be a 4. So the difference won't be the same. So then we look at another thing to say, what if we look at the quotient? What if we look at the ratio of the two numbers? Let's take term number 2 and divide it. Actually, let's divide term number 2 by term number 1. Okay, and term number 3 by term number 2. So if you say 4 divided by 2, that will give you 2. And then you say 8 divided by 4, that will give you a 2. And 16 divided by 2, that gives you a 2. So it means, because this is constant, but we are not getting the 2 by subtracting successive or consecutive terms, but we are actually getting a 2 by actually taking the ratio, of two terms, term number 1 and term number 2. Then this will no longer be called a constant difference, because it's not a difference. Okay, it's a quotient. Okay, it is a quotient. So because it is taken from the ratio of two numbers, the ratio of 2 and 4, then we can actually call it the common or constant ratio. That is the difference. So it means these are all sequences, but unfortunately we can't give them the same number, because in this one we have the common difference, but in this one we have the constant ratio. So when you have a sequence where you have a constant ratio, okay, where you find that the ratio between two successive terms is the same or is common or is constant every time, then we call that kind of a sequence. If you don't want to call it a sequence, you can call it a progression, because this is how numbers progress following a particular pattern. So when you say progression, or when you say sequence, you are actually talking one and the same language. Okay. Now, this is the difference between these two. The first one, which is arithmetic sequence, it actually has a common or constant difference that is found by actually taking the difference between any two successive terms. But a geometric progression instead is not having the common difference, it has the common ratio, which is actually found by taking the ratio of two successive terms or two consecutive terms. Okay, I believe this is simple. But now what we are interested in is how are we actually going to determine other terms in both sequences. If you are given an arithmetic sequence, how are you going to determine the other term? Okay, and then that is supposed to be given by the general term, which is Tn. The same thing applies here. I'm still going to be talking about Tn. All right. Now let's check. If you say you want the common difference, how did we get the 2? We said term number 2 minus term number 1 is equals to term number 3 equals to term number 2. We can actually verify this. Okay. So if we substitute the value of T2 by 3, T1 by so on and so on, then you get something like this. So you get 3 minus 1, which is 2, and then 5 minus 3, which is 2. So it means 3 minus 1 is equals to 5 minus 3, which is equals to 2. So if you get such kind of a setup when you deal with a sequence, then you know you are dealing with arithmetic sequence. And this is how you get the common difference. You take term number 2, you subtract term number 1, and then that must be equals to, it's a must. It must be equals to term number 3 minus term number 2. Okay. Whereas, on the other hand, we actually take the ratio. If you say term number 2 divided by term number 1 is equal, it must, like I'm saying, it must be equals to term number 3 divided by term number 2. Okay. So if we substitute, we can actually verify this. This is the same as 4 divided by 2, which is a 2, and then 8 divided by 4, which is also a 2. So if you get this kind of a setup with any sequence, where term number 2 divided by term number 1 is equals to term number 3 divided by term number 2, then you can confidently say the sequence or the progression is geometric. Okay. Now let's check the Tn. I'm interested in the Tn now. What is this Tn? Tn is actually, when you say Tn, you are saying number of terms. Number of terms. So we need to know how many number of terms are there in this sequence. Okay, how many number of terms are there in this sequence? And this Tn is known as the general term, or if you don't want to call it the general term, you can call it the nth term, provided this is n. If n changes to k, then it will be the kth term. If n changes to b, it changes to m, it will be the mth term. So, but under general and logically, we actually use Tn or Tk. Okay, so Tn means general term. Or if you don't want to say general term, you can actually use the variable and say nth term. And then if you don't want to say the nth term, you can as well say it is the last term of the sequence. So we know that this sequence will continue and continue up to the last term, but that term we don't know it. That is why we are saying we are speaking under general, and we call it general term. The same thing apply in here. Okay, so this will be the last term. You will see the importance of actually knowing that Tn is a general term, is the nth term and the last term when we'll be dealing with examples, which will be in the next video. All right. Now, in arithmetic sequence, the general term is given by Tn is equals to a plus n minus 1 into d. So in every formula in mathematics, you need to know what each and every parameter or what each and every variable represent. So in this case, when you say Tn, we know this is the general term. This is the last term. This is the nth term. It is given by a is equal a plus n minus 1 into d. That is how you read it. So the a that you see here is actually T1. So T1 and A1 is one and the same thing. So when I say find the value of a, I mean find the value of T1. Okay? And then n is actually the term position or the term number. Okay? So we need to know the position of this particular term or the term number. Okay? Now, so it's number of terms in simple terms. So we know that, okay, if we want to know the term position of 3, that will be T2. So that is why our n is equals to 2 in this case. Okay? Then The 2 that we are having here, we remember this is actually the common or the constant difference, and is represented by the very same D. So in this case, it means our term number 1 is 3, or our our term number 1 is 1, or our A is 1. Likewise, 2, which is our constant difference, is the D that you see here. Okay? But when you talk about geometric progression, the general term is given by Tn is equals to AR exponent n minus 1. But the variables, or these parameters, they still mean the same thing. When you see your A, you know you are talking about the term number 1. But when you see the 2, it is no longer the common difference, it is now the common ratio. Okay? It is now the common ratio. And you know why by now. Now your A is still T1, and then your N is still the term position of the term number. So under general, you can see that there are actually differences, but there are also similarities. Because what is the same here is T1 is A with arithmetic sequence, and T1 is still A with geometric sequence. Okay? And N is the term position or the term number, and then N in this case is still the term position or the term number. It's the same thing. Okay? So those are the similarities. But the difference between, or the distinction between geometric sequence and arithmetic progression, is that the general term of an arithmetic sequence is given by Tn is equals to A plus n minus 1 into D, whereas the general term for geometric progression is given by Tn is equals to AR exponent n minus 1. And another difference is that with arithmetic sequence, we talk about the common difference. But with geometric progression, we talk about the common ratio. So people, there are 2 variables that are very, very important in both sequences. In an arithmetic sequence, if you know the value of A and the value of D, then you can answer any question that you may be asked. As long as you know the first term and the common difference. Okay? Because you can see, if you know the first term and the common difference, you can always get the other term. Okay? Look at this. 1 plus 2 is 3. 3 plus 2 is 5. So on and so on. The same thing apply here with the geometric progression. If you know A, which is term number 1, and you also know your common ratio, you can always find any other term. So it means with arithmetic sequence, we take the preceding term, we add it to the common difference to get the next term. But with geometric progression, you take the preceding term, you multiply it by the constant difference to get the next term. A term multiplied by the constant difference, you get the next term, just like that. Okay. Now in some, you can easily say, okay, let's compare the 2. This is the overview. I'm just giving you the overview or the summary, okay, of the comparison between the 2 sequences, the geometric sequence and the arithmetic sequence. Right. Okay, we are still talking about arithmetic sequence and geometric progression. Firstly, in arithmetic sequence, T1 is equals to A. The same thing apply. In geometric sequence, T1 is still equals to A. This is similar. This is the same. Secondly, N represents the term position or the term number. Even in geometric progression, N is equals to term position or the term number. So this is still the same, it's similar. So they are similar with these 2 features. Okay. And then now, with arithmetic sequence, you have a common or a constant difference, whereas in geometric progression, you have the common or constant ratio. This is the distinction. This is the difference between the 2. Another thing is that to determine D in an arithmetic sequence, you take term number 2, you subtract term number 1, which must always be equals to term number 3 minus term number 2. You actually need 3 terms in order to define, at least 3 terms to define whether a sequence is geometric or arithmetic. Okay? Even though in most of the questions it will be given in the following arithmetic sequence, in the following geometric sequence. But if it is not given, you need at least 3 terms to define whether it is arithmetic or it is geometric. So if it is arithmetic, then the difference between any 2 successive terms or consecutive terms will be the same. Right. In geometric progression, we have what? We have R, which is actually found by taking term number 2 divided by term number 1, which is equals to term number 3 divided by term number 2. So the ratio of 2 successive terms. Okay. And then now, the general term for, or the nth term, or the last term of an arithmetic sequence is found by using the formula Tn is equals to A plus n minus 1 into D. People, please, the more you speak the mathematical language, the more likely you are to master that content. Okay, so you must always recite this. Okay, say it with your mouth. Recite it. Tn is equals to A plus n minus 1 into D. This is how you read it. Okay, right. Then in geometric progression, you will actually have Tn is equals to AR exponent n minus 1. And be careful here. The n minus 1 is one term, and then it's the exponent for the base r. All right. Now, in both cases, the Tn that you see here represents the general term, or it represents the nth term, or it represents the last term. So people, this will mark the end of my video for this session. And please don't forget to check my other videos. In the next video, I'll be dealing with examples and questions from previous question papers that deals with the arithmetic sequence and the geometric sequence. Okay, thank you very much. Please subscribe, like and share with family members, with friends, with whoever that may benefit from this particular video. The baseline is we want to educate the nation, and mathematically, of course. Okay. Now, don't forget to hit that notification button so that you'll be notified of my future videos. I will actually leave the links of other videos that I've already uploaded, so that you can actually check all the videos. Your comments are very important to me because they help me improve in my next videos. Thank you for watching, and God bless.